video on graphing radical functions, you should have a sheet of notes like this so that you can take notes as I am doing these problems. Okay? So we are going to be graphing radical functions. And unfortunately, there's not really a good way to graph radical functions unless you make a table. So we are going to make a table. And there's kind of two ways to do this. One where you have some approximate numbers and you kind of estimate, and one where you can get some exact answers. So let's look at this first one. We have y equals square root of x plus 1. And I have a graph here. It's got negatives and positives. And last year and some this year, we have used kind of the same numbers to graph functions. Namely, we've used -1, 0, 1, and 2. Sometimes we include -2. So let's go ahead and just plug these into our function and see what we get out. So when I plug in -1 for x, -1 plus 3 is 2. So the square root of 2, you can put into your calculator and estimate it's about 1.4. Okay, so again, this is an estimate. This is the one where you can estimate. If I put in 0, I'd have 0 plus 3, which is square root of 3, which is about 1.7. Again, these are all estimations. Next one, I put in 1. Ooh, this one's going to give me something nice. That would give me 4, which would give me 2. Next one, I put in 2. That would give me the square root of 5, and the square root of 5 is around 2.2. Okay, then I can kind of use this to plot my points. So the point -1, 1.4 would be about there. 0, 1.7 would be just a little higher. 1, 2 would be about there. And 2, 2.2 would be about there. Now the general shape of a radical function is sort of the opposite of a quadratic function. So it's going to kind of be a line like that. Okay, it's going to kind of be a curved line that ends up kind of straightening out. So this is kind of one of those where you have non-exact points, right? You're just estimating, and this is totally fine way to do it. There's another way to do it so that you always get an exact answer. So let me show you how to do that one. And you can choose either method. I'm good with either one, whichever one you prefer. So this one goes by kind of looking at the function and determining, okay, well, what could I put in there that would make that a perfect square? Well, I can tell you right now, if I put in -3 in there, that's going to give me a perfect square, because square root of -3 plus 3 is just square root of 0, and the square root of 0 is just 0. Okay? The next thing, if I put in -2, that would give me -2 plus 3, which would give me square root of 1, which is just 1. So here I have some exact points I can use. We already had one exact point over here, so we can use 1 and 2. And let's see, what would be another one? We could use 6. So if I put in 6, I would get 6 plus 3, which is square root of 9, which is 3. So this gives me some exact points to work with. Okay, and you can kind of see it's going to follow the same pattern. So I'd have -3, 0, -2, 1, 1, 2, and 6, 3. So really my graph would end up being just a little bit different kind of up here. But really they're essentially the same graph, okay? So you can either do this method where you're just plugging in and getting approximations, or you can use this method where you're kind of using what you know about perfect squares to get some exact numbers. I'm good with either one. Whichever one makes the most sense to you is fine, okay? Let me show you this one again. This one's going to be a little bit easier. And again, let's go ahead and just plug in our numbers here. And this one's going to be kind of interesting, because when we put -1 minus 1 in, remember we can't have a negative square root. So even if you put that in your calculator, it's going to come back with, hey, look, that's a non-real answer. That doesn't exist. So we can kind of put an x. Basically what that means is that at -1, our function doesn't exist over here, right? It only kind of exists on the right side. So then let's look at the next point. 0 minus 1, well, the square root of 0 is just 0, minus 1 is -1. When we plug in 1, the square root of 1 is just 1, minus 1 gives me 0. Okay? Notice that I'm doing the square root before I'm subtracting. That's because the subtraction is outside the square root. Okay? Then I'd have square root of 2 minus 1. Square root of 2 is about 1.4 minus 1 would give me 0.4. Okay? So now we have a couple of points to sort of work at. So this one, I'd have 0, -1, 1, 0, and 2, 0.4, so about there. So you can kind of see this one is going to kind of look like that. Okay? Now, again, you could do the same process over here where you're looking for some perfect square numbers. We've already got a couple, 0, minus 1, 1, 0. But instead of putting in 2 this time, maybe we could put in 4, because the square root of 4 is 2, and 2 minus 1 is 1. Okay? Again, maybe we could put in 9 this time, and the square root of 9 minus 1 would be 3 minus 1, which is 2. Okay? So this way gives us some perfect squares so that we can kind of check 0, 1, 4, 1, so it should be a little bit actually lower than we estimated it, okay? But again, these are fairly similar, so I'm not worrying about whether you have this line or whether you have this line, okay? If you like the method where you're just plugging in negative 1, 0, 1, 2, that's great. If you are plugging in this, that's fine too, okay? Either one works for me, so whichever one makes the most sense to you is your choice, okay? Thank you. Make sure this gets labeled into your notebook.